and I am going to be starting my stream now. As with last week, I'm very tired. May has been quite the month, and we are 4 days into it, so... and it looks like it's good. So someone was mentioning the other day on one of the YouTube videos that the quality wasn't very good, and it looks like we're holding steady at 720, so let me know if that drops too much. Let me pop out the chat so I can make sure I can keep an eye on it. Okay, so today, the last couple weeks, we've been working on the replication project, the Beware of Geek Sparing Tweets, or also it was called the Shy of the Character Limit paper. I think I called it that a couple times. That is the actual title of the paper, so that's probably the better thing to call it. But yesterday, somebody at work emailed me and was like, hey, I've got a bunch of people with different job titles, and I want to find out how similar individual job titles are to these other job titles. And I got really excited. I was like, oh, that sounds like a super cool question. There's, different ways that you could do it. And I started just like rattling on and on and on. And the person was like, Rachel, I don't have an NLP background. Maybe I'm not following you. So I was thinking it would be interesting to do it as a stream. And also just sort of like a nice little brain vacation for me, because we're kind of in a rough patch in the thing that I'm doing, the paper replication project. So without further ado, let's get started. So the package I am hoping to get to use, this is also like a little bit of a learning project for me because I haven't used this package previously, but it seems good. Like I don't know. Like when you smell a package, it's not smelling, when you get like the idea like, oh, this could be interesting. So this seems like a very interesting and useful package. It is called Text2Vec, and that is very small, so let me make it bigger. And it does a variety of things, mainly vectorization. So vectorization is taking a set of words and creating a multi-dimensional space and putting each single word in a specific point inside that space. So the simplest way to do it is that you have, a co-occurrence matrix. So I would have a row for every word, a column for every word, and then in each row and column I'd have the number of times that those two words co-occurred. But the problem with that is obviously that the matrix is going to be the same size as your vocabulary. And I think we're actually probably going to be in that realm today. And there's lots of, clever ways of taking that really large matrix and projecting it down into a smaller matrix where you don't have the same number of rows as rows and columns as the rows in your. So the number of rows is not the same as the number of items in your vocabulary. Ooh, sorry, it's been quite a week. Maybe I shouldn't do these last thing on Friday. Anyway, so this does really efficient vectorization because it's actually written in C, or C++, and then R is just sort of like a wrapper API around it, so it's super, super fast. The one thing that people tend to rag on R for is that natively matrix transformations tend to be a little bit slow, and for vectorization and embedding, those are, so vectorization is what you do to get to the embeddings. There's a lot of matrix flipping and stuff. So if you were doing this in base R, it would be a little bit slow, but this seems very interesting and potentially useful. And so with this particular embedding set, which is trained on a much larger corpus, is GLOVE, which is out of Stanford, and it's global vectors for word representation, but people just say GLOVE. So this is we're not going to go through this. So this is the GLOVE algorithm and all the things that happen. And the really interesting thing about vectors and why I want to use them is that there's this idea that words that are used together more often tend to have meaning that is similar, right? So you are more likely to talk about animals together in the same context than you are to talk about animals and like something unlike animals. Ugh. Boats, right? So boat words and animal words tend to be used together within each group and tend to be used across the groups a little bit differently, a little bit less commonly. So this distributional hypothesis, sometimes said, you shall know a word by the company it keeps, which is by, this is a very famous quote by somebody, John Firth. So this idea is that you can capture something about meaning by looking at words that co-occur. So this sort of multi-dimensional space that you are projecting your words into, and where words are points in space, is capturing something about meaning. So words that are closer together have similar meanings, and words that are farther apart have more different meanings. And because words are being stored as, well, I keep saying points, they're being stored as vectors. You might also have heard of word vectors. The nice thing is that you can look at these vectors and you can compare how close they are using the cosine similarity. So because these are vectors, so they're sort of like pointing off into space, and then the cosine similarity is just, the distance between them. And that is a very fast introduction to sort of the math behind it in a very sort of shallow way. But there's lots of different ways that you can learn more about this. I think there's a Dravsky and Martin chapter. Let me double check. Dravsky and Martin. There may or may not be a Dravsky and Martin chapter on that. Definitely they have both written about it. Anyway, sorry, that was off topic. Dravsky and Martin is the big NLP textbook, which at this point, it doesn't have a lot of deep learning stuff in it, so it's still good to know and really good for smaller applications, but maybe not quite state of the art anymore. Not that I wouldn't teach it. So the specific thing that I'm going to hopefully do today, and we'll see if this happens, is I'm interested in looking at something called the word movers distance, which is a specific way of getting this cosine similarity when you're looking at multiple words together. So this works really well for looking at two words, and we want to know if horse and cow are similar and tend to be used in similar contexts, but it doesn't really work great if we're interested in knowing whether the cow is in the barn and the horse is in the house are similar sentences. So for sort of multi-phrase comparisons like that, the word movers distance, which is this, is, I wouldn't necessarily say the standard, but, a fair number of people use it. And it's related to the earth movers distance, which is a way of comparing distributions, where you sort of like imagine that the two distributions you're comparing are two piles of dirt, and how much dirt would you need to move to make dirt pile number 1 look like dirt pile number 2. I'm using my hands and you can't see it, but imagine that you can see it. And the word movers distance is sort of the same idea. How much would you need to move these words through vector space? What is that sound? What is that awful sound? Hello, Chavana. So the question for the word movers distance is how much would you need to move words through this vector space that you've projected your words into in order to transform sentence 1 into sentence 2? Okay, so that was a lot of math right off the bat. Unfortunately, we don't have to implement this by hand because that would be fairly painful. Well, it would be doable. But I think that the resulting algorithm, if I were the one who wrote it, would be pretty gosh darn slow, because optimization is often not the thing that I am most concerned about when I'm programming. Fortunately, I think Dimitri is very concerned about optimization, so I'll just use his code instead, and we'll both be happy. So I said I was interested in word movers distance, and lo and behold, that's not it. Lo and behold, hi Canadian side, it has already been implemented in, hopefully, a very efficient way. And like I mentioned at the beginning, for those of you who weren't here, this particular package is actually an R language wrapper over a C++ package. So it should be very efficient, especially for all the matrix stuff we're going to be doing. Oh, and you can, if you are interested, you can go and check out the original article, which is here. And there is the exact same figure that this is the one that everyone uses when they're talking about word movers distance specifically. So my thought was that what we could do is we could look at job titles and then have a way to get the word movers distance between two job titles. And then, because we were interested in looking at how a specific job title, how far it is from a bunch of other job titles. So we can take the distance from all of the job titles in the group, and then we can look at the, probably the average distance. Or we could look at the distance to the centroid. So I keep talking about word embeddings as being sort of like points in this multidimensional space. If you have a space, you can sort of like have a blob around all of your points and then look at the center, and that's all a centroid is. So we could also look at the distance from the embedding for the specific job title we're looking at to the centroid of all of the different job titles. Yeah, and like I said, I haven't used this text-to-vec package, so my gut instinct is we're going to spend most of the day today figuring out how to use the package and sort of getting used to the API, and relatively little futzing about with the sort of high-level math, but I could be wrong. Let's find out. So I'm looking at job titles, so I'm just going to go to datasets, and I'm going to search for jobs. If I wanted a job, I'd search on the jobs for it, but I'm looking for lists of job, which is slightly different. And I don't want anything huge. 19,000, it's a good number. Because the eventual, thing that we're looking at is not going to be super, super big. It's for the Bachelor. I don't think I've mentioned that. Delvana says, please stream more often. Yeah, maybe. I need to run it by my manager. Let's take a look at this and see what it looks like. All right, job description. Is there a job title? Oh, actually, let's look at the column metrics. It's probably going to be more useful. Job board, job description. So those are really long. Job title, 1.9K unique. Monster probably isn't a job title. That's probably like a parsing error. I am a little bit skeptical about how clean this data set is going to be. I guess it doesn't matter super much because we're more sort of like, here's the implementation and less, here's the final project. Let's check out this one. Is this the one I just looked at? It is. And like any of these would be fine. I'm just being picky. Chrono803 says, Monsters Inc., a new company? Very possible. Very possible. I guess it could be for, like, Disney when they're hiring actors. I'm liking this one. Let's see if that is warranted. Because the only thing I need from it is the title. Oh, yeah. Chief Financial Officer, that seems like a real job title. Full-time Community Connections Intern, paid internship, Country Coordinator, BCC Specialist. Yeah, I'm feeling that. Okay, let's do this one. Let's start a notebook, and let's call it something helpful, like job distance. Actually, I'm interested in word movers distance. Word movers distance for jobs. Except that should absolutely be I actually want it to be an R instead of Python because this text-to-vec package is an R package, not a Python package. Give it a second to think to itself. And I'm not actually going to load in the tidyverse, which I know is, Rachel, you always load in the tidyverse. But the text-to-vec package is not at all part of that ecosystem, so it'd be a little bit weird. So, library, text-to-vec. Awesome. I did check to make sure that it was installed earlier, and I had no problem. But there's always that, like, did somebody update the Docker image and uninstall it or something? And I don't know if I've mentioned this before, but our Docker image is open source, so if you want to update it, you are free to. Alan Au asks, is there a comparable package for Python that you use/like? If I was doing this in Python, I'd probably use NLTK, the Natural Language Toolkit. I don't believe it's implemented in Spacey. I like Spacey because it tends to be faster than NLTK. I like NLTK for research stuff or sort of like different interesting things. My biggest gripe with NLTK is that it tends to be pretty slow. Like most people I know do not put NLTK code into production. They're more likely to use something else that scales a little bit better. It's a research package. I'm trying to think if Stanford NLP has word move as distance, and I don't know off the top of my head. I want some of these. That was fine. And I was working for word movers distance. Text effect. Looks like no. I bet this is a Python package. Yeah, this is a Python package. Oh, okay. So it is either in Spacey or has sort of like a Spacey compatible thing. Yeah, I'd probably try this out. It hasn't been tested on Windows, so yeah. Yeah, so I would probably use this package if I were trying to do the same thing in Python. So what are we doing? The first thing we're going to need to do is read in our data. Jobs, read.data, read.csv. My mouse said the wrong thing. My finger said the right thing. And I don't think this is a huge data set. Could be wrong about that. Oh, this was funded by the American University of Armenia. Thanks, guys. Okay, it is read in. And I believe there is sample code. So I found what looks like somebody's sort of like text, not textbook, cookbook. So a bunch of sort of like things that work. And they worked with word movers distance, I believe. Okay, so it looks like they didn't work with word movers distance. They just looked at the cosine distance between individual words, which could work fine. So this is for an individual word, and it's not for a sentence. So we could also work with that. We could do like, I don't know, average, median, whatever sort of measure of central tendency or summative measure we were interested in. Okay, let's see. And I'm pretty sure there was sample code in some LaTeX issues. Here we go. So this is some sample code, and this generates an object of this sort of custom class, which is not linked. All right, so let's just read the documentation super carefully, because this is going to be, I have the distinct impression, fairly involved. I don't think it's going to be particularly plug and play in terms of just like sticking things in and getting stuff out. Oh yeah, Jensen would work. Yeah. Gentix asks, re-similar Python package, what about GenSim? Yeah, absolutely. Okay. Oh, that's the wrong function again. All right. Calculating how hard it is. Blah, 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 blah. Okay, we already talked about that. So at R6 class object, progress bar logical equals true, so you could see a progress bar if you have a big corpus. For usage details, see methods, arguments, and examples section. So I don't know what happens after progress, probably just progress bar equals true. And then, so this distance to matrix that this person is making here is made, is a method of this relaxed word movers distance object. Okay. So here's the constructor. So this is how we would make the model given a set of word vectors that we would have to train ourselves, which should be pretty fast again, because this is an R wrapper on C++ code. I would not try to do this in R live in front of an audience for a fairly large corpus. And then computes the distance between each row of sparse matrix X. Is that an X or times? Times. And each row of sparse matrix Y. Okay. Computes parallel distances between rows of sparse matrix X and corresponding rows of sparse matrix Y. So this is the parallel distance and this is the regular distance. Word vectors, like I said, so that's going to be our input. It also needs a document term matrix. And a sparse, so those are the same. Oh, okay, so if we don't specify y, we'll get a matrix of x times itself. Or a tensor of x? Yeah, we assume y equals x. Oh, so we could use two different matrices if we wanted. And then the method is Euclidean or cosine. And I would agree that you probably want cosine rather than Euclidean. So distance equals 1 minus the cosine angle between the word vectors. Okay, that pretty much makes sense to me. And then there's a little data example here. So let's try running the example. And I'm going to have to go in and take out the number in this similarities bit. So let's try running the example and see how that works. So this is something I will often do when I'm working with somebody's code, and it's just to make sure, it's installed correctly and it does what it's expected to do. And let's actually go through bit by bit and figure out what each of them is doing. So it looks like this first little bit, so this is data that's in the package, I'm assuming. So it's just a data object that's shipped with the package. So we tokenize, so we break into individual words, which you need to do for a, if you're creating word vectors. Then we create a vocabulary. So this would be just like a list of all of the unique words that we have, would be like a dictionary in Python. With this I token, which I think is probably going to be an iterator that's going to iterate over all of the tokens that we have. And then prune vocabulary, so dropping all very rare words. So sort of like, you can think of word, what's the word I'm thinking of? Occurrence? Word existence? Seeing words? Frequency. You can think of frequency as sort of a long tail distribution. So very few words occur very often, and many words occur very rarely. So we're just cutting off a lot of those very rare words. Which makes sense because it's going to make our matrices a little bit smaller and increase efficiency. And then we're creating an iterator that we're going to refer to again. We could probably just create it once and then do it here twice. And then we're going to vectorize our vocabulary. So let's actually really quickly just take a little bit of a peek at this movie reviews and see what that looks like. So I should now be able to do movie review, and let's just see the head of it and see what that looks Okay, so this is just the text of movie reviews, it looks like. So this is going to be quite a bit longer than the text that we are using for our job titles, because you can see these are like 50 to 100 words, and our job titles are like 8, 10 words. I can't see it. Give me examples. Accountant, chief accountant, medical sales manager. So we're going to have much smaller individual documents, and it looks like they're also tagged for sentiment. So 1 would probably be they liked the movie, and 0 would probably be they didn't like the movie. Rating below average, bottom of the barrel. Yeah, 0 is they did not like the movie. Okay, so at the end of this, we should have... Oh, that was fast. That was real fast, because we did all of the vectorization right there. I'm pleased. I was expecting that to take like a minute. I was gonna have like chit chat all prepared for you. That was speedy. I'm very impressed. So let's take a peek at what this vectorizer looks like. Assuming we actually... Oh, okay. So we didn't actually vectorize it yet. That would do it. So it looks like a... So it looks like the thing that we're going to iterate over to vectorize it. So we're going to need to make our document term matrix and our TCM. What is a TCM? TCM. Yes, that's the one I want to know about. Oh, term co-occurrence matrix. Okay, that makes sense. Are we using glove? Yes, we are using glove. Okay. So we haven't actually yet made our word vectors. So let's do that and see how long that takes. Okay, this is taking a little bit longer. Okay, so this is all pre-processing. This is creating the objects. It's still pretty fast. Well, it's not bad. Let's see, 10 epochs, it took about that many seconds. Not that many seconds. Okay, that's not too bad. So we should at this point have word vectors. Let's look at the structure of that and see if that is in fact the case. Yeah, nice. Okay. So this is what I would expect word vectors to look like. So we have like 1,300 rows, and we have 50 columns, and each. So we have a sort of a 50-dimensional space that we're working in, and then we specify where in space along 50 different axes each word is. So miraculously is at these coordinates and it continues for 50. Hillbillies is at these coordinates and it continues for 50. And 50 is sort of like the smaller side of embedding. I think the glove embeddings you can get off the Stanford website go up to like 500. And I'm pretty sure the fast text embeddings go up to 500 as well. Generally, the more embeddings you have, I mean, the longer things take and the harder it is, but the better results you can get because you get sort of like finer granularity. Okay, so these are our word vectors. And these are the word vectors for the reviews, which we specified here, that we're just looking at the reviews and not the rest of the data frame. Okay. So here we are getting an average of main and context vectors as proposed in glove paper. Okay, so this is the word vectors we had plus the transpose of the context vectors from the glove model that we built when we were building the vectors. And then this is our relaxed word movers distance, and this is the call that will make a new one. So this creates a new model, And then we're getting the distance. We're looking at the actual distance for the first 100 words for the first 10 dimensions using the new model that we initiated up here, and we're not normalizing. Okay. I should actually probably put both the I'm making a word vector stuff in the same cell, because that's going to take the longest to run out of all of these things. And I think it's also useful for like my personal, mental keeping track of things, to move things into different cells if they have conceptual similarities. Okay. So we are just looking in our document term matrix at the first 100 words and the first 10 rows. And then here is the relaxed word movers distance. So this, I'm a little bit perplexed, because this looks like a transformation of the vectors we had already, and I'm a little bit confused what the distance is between. Let's go back to documentation. What is your distance to between? Let's see, dist2, I believe, is the function. Okay, calculates pairwise distances / similarities between the rows of two data matrices. Note that the same method, some methods work only on sparse matrices and others work only on dense matrices. Ugh, woof. Everything should be sparse at this point, though. If I am right in my mental model of what's happening, all of our matrices at this point should be sparse, except for the word vectors themselves, which are not. Okay, so when we created it, we gave it all of the word vectors, and then we compared that to the document term matrix. So is this the distance from the centroid of all of our... So is this basically a topic model of all of the movie reviews that we have? And we're looking at the distance of this sort of slice of our document term matrix from all of the movies reviews. So this would be a measure of like surprisal. So the bigger these numbers are, the more surprising the word is. I'm also noticing with my eyes that they get bigger as you go across. Except for this one. This one does not. And this one, and this one, and this one. Okay. So we're looking at the first 100 words and then the first 10 rows. So these distances are very small, which leads me to think... let's point out the first 10 ones. Does looking at the dimensions of the matrix tell us what it's comparing? Alan now asks. I'm pretty sure the dimensions of this matrix are coming from this. Wait. I think I was all wrong. I'm wondering if it's pairwise for all the words. I think we are comparing the first 100 rows to the first 10 rows. I think is what we're doing. Yeah, I think it might be pairwise for all the words. So if we do... Okay, first let me check this out. Let me see what the dimensions of the RWN. Let me see what the dimensions of this are right now. Okay. So it's 100 by 10. And we fed it in 100 by, 50? What was our document term matrix? Anyway, so we fed it in the first 100 rows of our document term matrix, and then we fed it in the first 10 rows of our document term matrix. So, okay. Let's look at the first 11 rows of our document term matrix. I think this will tell us something interesting about what this is, and we want the first 1 through 11 because we count from 1 in R. All right, so what I am expecting here is that it should be very little going across all the way to 10, and that is correct. And then starting here, we no longer see that. Okay, yeah, Alan is absolutely correct. It's a pairwise comparison for all the words. So the reason that it's very small along this sort of like diagonal here is because this is comparing the word to itself, and then the second word, the third word, the first word, the fourth word, I can count. And then this is comparing this word to the first word, the second word to itself, second word to the third word, and so on. So we're comparing all of the first 100 words to the first 10 words. So pairwise comparison of the first 100 words to the first 10 words. Okay. So what we could do is we could do the distance. So we could take a document term matrix of, do they need to have, so the same document term matrix, yeah. Alan says, it looks like it's symmetrical around the diagonal. That is what I wanted to say with my words. Yeah, but I don't think it's pairwise for all words. I think it's only pairwise for the first 10 words, and then for the next 90 words, it continues on down on its own way. So I'm trying to think. So the document term matrix, let's look at the structure of this. So the one thing that I'm thinking about now that might be a little bit tricksy is making sure that we're comparing one job posting to another job posting, or one job posting to a bunch of different job postings. So let's look at the head of the document term matrix and see what that data structure looks like. Nothing. It looks like nothing. Okay, let's look at the structure of the document term matrix. Okay, so package matrix with 6 slots. How many reviews did we have in our original data set? I don't think this is telling us reviews, maybe? I think it might be telling us, Okay, let's look at the dimensions of the original reviews data set. Movie underscore review. So that is 5,000 by 3. So the only thing that is 5,000 here is this @dim slot. So can I take the first document from here? So can I do DTM @dim and then take just the first one? No. Can I do that? Okay. Oh, that just stores the number of dimensions. Okay, that's not helpful. Let's see. So what I'm thinking is maybe, I don't see anything here that's higher than 5,000, so maybe @I is telling us the index of the review that it comes from. Basically, I want a way to get a document term matrix that's just a single, in this case, review, and then later on when I'm working with it, it can be just a single job title. Let's see if there's anything in the document term matrix here that might be helpful. Let's see. DTM, nope. DTM, there we go. Create DTM. Are you going to tell me about this? High-level function for creating a document term matrix. if a parallel backend is registered, then the first argument is a list of iToken iterators function will construct the DM in multiple threads. User should keep in mind that he or she should split the data itself and provide a list of iToken iterators. Each element of IT will be handled in separate thread and combined at the end of processing. Okay, so that's just if you want to speed up with parallelization. Not super helpful for what I'm looking at right now. iToken list, iToken parallel. We don't need to worry about that. And we could parallelize it if we wanted to. But I'm not especially interested in doing that right now. I think we're fine. It was not that slow. Okay. And this is the same code that we had earlier up to... No, it's actually pretty different. Example of parallel mode. We made a TCM because we were looking at... I don't want to create a separate document term matrix. Oh my god, I'm so dumb. We just need to look at the words in the document term matrix that are in each job title. I'm so dumb. It's very simple. Wowzers. Holy beans. Okay. So, we can get rid of that because that's not going to work. Let's tidy these up since I've restarted my notebook by being a person who clicks in places. I don't need that. I don't need that. I don't need that. I feel this is not going to work above the code where I create the object. Oh, and I'll just run it all from the top. Yeah, so the only thing we need to do is just iterate through our so tokenize and then get the unique tokens for each little bit of text that we're interested in, and then feed get the rows of the matrix that correspond to those same words, and then compare them to the ones for the rest of the job titles, and it will be pretty straightforward. And then we can take, like, I don't know, dot product or something, just sort of some summarization of how big the numbers in the data set are. I can't believe it. Oh my god. Okay, so this is going to be actually fairly straightforward. And let me do just like a little bit of a proof of concept. I don't actually need that. With this. So just to see how it's like to interact with the document term matrix. Okay, so I want to get out specific words from the document term matrix, and I think, where is it? I think he does this in this cookbook. Dist2. Okay, so this is the distance matrix. So let's do let's actually grab a real sentence that exists so we don't get out of let's take the 10th sentence. So let's do this. The ladybug's face is a clear reference or a tribute to Peter Lorre. So sent one. Oh, and just to keep it consistent, I will use equal sign sent to. Oh yeah, this is a text string. It's not going to work if I just pretend that those are all actual objects. And then so we can just do our little word. Actually, I think we just need to get to tokens from each of these. So I think I should just be able to tokens send one to this. Let's find out if that works or not. And then if we look at tokens. So tokenization is just breaking, there we go, a word apart. There we go. So you can see that all of our punctuation has been removed. Everything's lowercase. It's all nice and tidy. And so all I need to do is find these words in the document term matrix. So, should I do this with a loop? In general, loops in R are pretty inefficient. It's like, I want to say worse than quadratic time, so you should probably avoid them in general. This might be a situation for it, especially since job titles aren't very long. And I have 15 minutes and I do have to get my scooch along because I'm not going to have a lot of time to work on this next week, so it should be more or less done by the end of the 15 minutes. Let's check out the structure of this document term matrix again to see where I can plug these words in and get the documents out. So it needs to be, so we're looking for DTM, and then the dim names, and then we want, let's take the head of that and see what that looks like. It looks like nothing. Oh no, I think I printed out way too much stuff. Oh, okay, no I haven't. So I should be able to take it just by index here. If I can ever scroll up. I did print out too much stuff. So I want the second one, and I think I actually am going to ask for, so what I'm thinking of, is this a vector? Let's see if I can do this. Does it skip me an error? Oh, it might. Okay, I was just looking for miraculously. So it might be that. Will that get me too many things? Okay. So looking for the second dimension. Let's just get the structure of this. Sorry, this is, like I said, I'm not super familiar with this, this package, and it's got a lot of, okay, so at this point it's still a list. So I think I might need to say to, and then look at the first item in that list, and then get the first item from that vector. At that point it should be a vector. Ooh, sorry about that. That was not a great sound. No, it's still not a vector. Okay. So what I'm trying to get is I'm trying to get at individual words here so that I can goulad. So I can look for these words that we've tokenized in that list of words. And I'm having a little bit of difficulty. Oh, duh, it's a list. Yeah, okay, so I need to select the first object. So this is, to select objects from the list, you need to use double bracket notation. Let's just, or you could use $sign notation. Excellent. So can I, is this gonna be fast? This may be very slow. Let's try it. This is very slow. Oh, okay, so this is looking for all of these in here. I always get in backwards. Let's try it the other way first, because again, I always get it backwards, and see if that works. So I just want to see, so I want to get the words from, so I want to get, so at this point we have a list of all of the words in the document term matrix, and this is sorry, this is not a list, this is a vector. So we have a vector of all the words in the document term matrix. And here we have another vector, and I want to get I want to get all of the, I want to get the document term matrix that is made up of the embeddings for each of these words. So we're pretty deep into the nitty-gritty of how this package does objects. And I think this is not going to be a very efficient way to do it. But one thing that I could do is I could, oh my god, this is going to be the slowest possible way to do this. This is not very efficient. No, you don't have to. You can stop. Is what I can do is, so this is the list of words. Instead, oh my god, I can do, maybe. So we have here a Boolean vector, and I can use that to filter here, maybe? Well, that wasn't it. Okay, well, now we have a character output rather than a list output, so that's a change. I should probably just read through the documentation first and see if there is a easier way to do this that's already built in for us. Split into, maybe? Let's try that. Oh, nope. That's for parallelization. Okay. Let's go to the website. Nope. Nope. Yes. And take a look at some of this sample code. Fitting models, transforming the fit. Par with any other model, second low rank matrix is available in components field. Note that in all models that will inherit, the matrix will have okay. Well, both of the word vectors matrices can be used as a result. It is usually a better idea to average or take a sum of the main and context vectors, which we did. Are you kidding? Is it just, can I just do it like that? Okay, let's see if this works. I think I've been futzing around, and actually the syntax is very easy the entire time. Let's see if this works. Instead of word vectors, ours is called WV. So let's use that instead. Word vectors, and let's try just this. Subscript out of bounds. NA. Okay. So let's see. Main plus context. So this should be a word vector because they're looking at the distances between these. Maybe I can just ask for it like so. Oh, not like that. That's not gonna work. Can I just get rid of all of these? No. Okay, so that also gets me NA. Maybe I should ask for 1 through 50? No, subscript out of bounds. If I ask for the first, that's also not gonna work. What if I ask for the first thing? Okay. 1, and I want the first 10. Okay, so this should be for miraculously. Can I get the name out of this? I think this is a named list. Could not find function name. Null. Okay, so it's not a named list. Let's look at the structure. Whenever I am really stuck about how to interact with an object, I always look at the structure, and I eventually figure it out. Okay, and if I just do the first one, it's numeric. And if I do 2, it's a named numeric. And I think there should be... Okay, so there's 50, because that's how many dimensions each. Let's do the first 10. So 50 dimensions is how many we have for the embedding for each word. But if we have more than one dimension, suddenly the name attribute goes away? That's very odd. Either 2 or 3 arguments are required. I think it's called name? Object name not found. Fascinating. Okay. I don't know how this object works. I don't know what's going on here. I'm fairly confused. Okay. Because what can I do by name instead? I cannot. Fascinating. Okay. I'm a little bit confused because, again, the documentation suggests that this should work. Well, let me double check and make sure that this is after we've done the context adding, because that could be relevant here. Let's see. Yeah? Yeah? So this is what we did. I guess I'm going to zoom in a little bit more. Whoop. So this is what we did. We did fit, transform, TCM, number of iterations. Where is it? Fit, transform, TCM, glove, number of iterations. Okay. And then the main plus the transpose of the glove components. Main plus the transpose of the glove components. We did the same thing, but then at that point, he could get the words based on the name. Okay. So, what do we do different? Is it because we're not using glove? I'm pretty sure we're using glove. I'm pretty sure we're doing the exact same thing. Glove, new, word vector size, vocabulary, x max. Word vector size, vocabulary, x max. Global vectors, new. Glove. Oh, maybe it's the difference between glove and global vectors. Let's see if that'll change it. Is global vectors not a thing? All right, double check this. Global vectors. So where is this from? This global vectors thing. Where did this happen? It looks like it should be in the package. Glove object will be modified by fit transform call. Ooh, modified in place. That is good to know. Let's see if this is global vectors. It's in the documentation. Class for glove word embedding model. Okay, so it looks like the same thing. Yeah, okay, so in the documentation it's glove instead of global vectors. So that looks like it's just been changed. Let's try running it all from the top. That might be our problem. So we have our tokenized words. So the problem that we have now is just, I want to be able to get the terms out of my document term matrix that are the terms that are in each of my, text targets. And I'm having a little bit difficulty with this. So we're having the subscript is out of bounds. Maybe it cares about single quotes versus double quotes. R usually doesn't, but this is a wrapper, so it might, because it's going to an API. Okay, that did not fix it. What if I just ask for 1? Subscript is out of bounds. Do we already look at the structure of word vector? Okay. But the thing is, it doesn't have a name. Can I just say 1? Will that do it? Much be a mode character. So it's an attribute, but it's not a named attribute. So it's a named numeric matrix. Let's get rid of this one. Okay, so R search named matrix by name. Okay. We can then retrieve the first member by its name. Alan asks, how are we indexing into word vector? By row number, string? So it looks like from the documentation, you should be able to do it by string. So this is a word vector made in the same way as we made ours. And he is indexing by string. But when we try the same thing, so we try this, I'm just going to copy and paste. So when we try the same thing with our code, except this is WV and not word vectors, we get this problem, subscript out of bounds. And if we try with 2, we get subscript out of bounds. But if we try it with a number, oh, okay. Well, previously when we tried it with a number, it did something. It might be easiest to get the index the indexes of these from the list of names. So is that gonna work? No, that's not gonna work. Unexpected numeric constant, because it's an unnamed attribute, which is the hard thing. Because usually you can access attributes by their name, but they do need to have some sort of name. And you can see if this is it looks like a named matrix, or a matrix where the rows are named. So we should be able to just retrieve by the text. I guess we can just try indexing by token sentence 1, but I don't think it's going to work. Yeah, it does not work. Invalid subscript type list. Okay. So maybe we need to say, so those are the rows, and maybe we need to say that we want columns 1 through 10. Subscript out of bounds. But this is definitely, so we can definitely do like 1 through 10, right? Because it's just a matrix. Yeah, so that works no problem. We just can't do it, let's see, 1. We just can't do it with, so this should be the word this. We just can't do it by name, which is weird because we should be able to. Maybe it doesn't like that we're, will that work? Okay, no, that doesn't work. Maybe it's the columns that are named? Surely not. Surely that's not the case. Yeah, okay, that doesn't work either. Okay, let's double check the structure of this. One more time. So it's a 2-dimensional matrix with 50 columns, 13,000 rows, and it has a null attribute, and it has this character attribute that is its the name of the word that is associated with each row. And I think we had a whole big thing earlier about looking at the dim names. I'm trying to remember what the exact was it at? Let's double check. Let's go back to this again and then look at the word vectors. Yeah, it's a numeric matrix. Each row should represent a word. And dump every blah blah blah. Okay, so these are, so this is the global vectors. Glove object. And then it should put out this word vector, and then we add the context. This is deprecated. Oh, maybe that's the problem. Okay, so we're retraining with lowercase glove. We weren't. Let's try it. Let's see if that fixes our problems. Or maybe it'll give us a bunch of errors. That is also possible. Yeah, okay, that didn't work. I'm struggling. I'm struggling a lot. Also, it's well after 5. I want to solve this though, but also I have something at 6 that I need to get ready for. A little bit longer. A little bit longer. So the word vector object. I just want to get things out by their names. Numeric matrix would contain words embeddings, rows, words, columns, corresponding vectors. Rows should have word names, and they do, but I can't access it by it. Our numeric matrix index by name. What if, how about this? What if we try and get the names out of our word vector? That didn't work. Okay. But didn't have didn't have a dim names attribute. I'm making that up. I felt like it did. Or was that the document term matrix that had the dim names? Maybe we should be working with the document term matrix instead? Okay. But it also doesn't have dim names, and then I want the second item from that list. Okay, let's just call this word So that is the list of the words. And then we can get the index. All right. Can we match maybe? Can we do match? So can we match in words? Let's say this. Will that work? I think this might not be the right function for this. R get index of term from vector. This is a very simple thing. This should not be hard. Free vector members with the square brackets operator. Out of range indices. NA. Is there like a G sub thing? There might be. R get the index of matching items from vector. Oh, it was backwards. So it should be match this words. All of these words should exist. Sir Sniff asks, which was the first programming language you learned? Visual Basic, believe it or not. I don't use it anymore. It was not a great language. And certainly not good for data science. I hope nobody's doing data science in Visual Basic. Okay. X in. Let's see if this will work with our whole vector. We have a vector of names, which is the important thing, but I'm having a hard time getting the word out of it. Let's look at the structure of words. Because I'm thinking, okay, that's a character vector. Yeah, this should work. Why is it weird? Why is it doing this? So we're looking for words, and let's start with this. But if that works, then we can do our whole little sentence vector. Well, nothing has been returned, so that's helpful. I'm just gonna unlist this for my sanity. Is it really just that we like pre-processed too many references? This movie is full of references. Okay, and what about this one? Full. Oh, okay. I've fallen afoul of my stop words being removed, I think. All right. Let me leave myself some little notes. I do need to wrap up. I need to get going. Words in our DTM, and then this is get the index of words in our sentence in the DTM, and it's not just the index, it is the row index. Oh my gosh. And then we can get rid of all of these. And then, okay, so from here, it's relatively straightforward what we need to do. Tokenize our sentence. So all we need to do now is put all of our job titles into a document term matrix, and vectorize them, and then compare the set of compare the words from the set of job titles we're looking at with the other one that we're looking at. So instead of this, it would be the output of this as the rows, and then instead of this, it would be, again, the output of those. So Steph says, any special reason for learning R or just curiosity? So my PhD is in linguistics, and I did a lot of behavioral research, and the statistics for that I learned R for. So I come to it from the sort of statistical behavioral side of it, and then as I did more and more NLP, I got more and more into Python. And usually I would use Python for this, but like I said, I was interested in playing around with this text-to-vec package, which is much faster. Yeah, and I am absolutely impressed with the speed. That was very fast for vectorization. 10 out of 10 would use again. And it's not it's not the package author's fault that I am bad at figuring out what objects are like. So all those times it was returning NA, it was actually absolutely the expected behavior, and it should have done that the whole time. So I can actually let me finish my little toy example. Just so I can have a full working thing to come back to later. Do this. Make sure that I change all of these so I'm not comparing itself to itself, and I will write functions for these if I continue to work on this project, which I think I will. I think this is sort of an interesting thing. And then, okay, so I should get, oh, I made a mistake. Oop. Yep, that'd do it. So now I should be able to get word movers distance. Oh my god, I'm gonna be so late. I have no previous experience with Python. No, I use Python all the time. I use both, and Bash a fair amount. Those are pretty much the big three. I guess Perl, and as far as I use both. I guess I use Perl, and as far as I write regular expressions, but ideally I keep that to a minimum, because let me tell you, if you are bad to begin with language processing, regular expressions do not make it better. And that should give us an error. Index is larger than maximal 5,000. Is that from the document? Well, those are from the document term matrix, which has more than 5,000 rows. Okay. Oh, okay. That's right. That's right. Oh, okay. Because when we added the, we transposed it when we added the context. So these should actually be in the second. Oh, you know what? I think we transposed it twice because we ran it twice, and it got modified in place. So I think this will work if we ran again from the beginning. But I do need, oh my god, I'm going to be late. I do need to go get ready for the thing I have at 6. So thank you for joining me, guys. Hopefully this hasn't been frustrating to watch. It was medium frustrating to do, but I feel like we made a breakthrough, and I'm fairly happy with it. I need to go through and clean up all this stuff, though, and also do it on the actual data I'm interested in instead of random other data. And I am going to make my style a little bit more consistent. And I will be back next Friday. Very tired, again, because I'm going to be traveling all week. But I'll talk to you guys then. Bye.